Good evening, Manula. My name is Sachin, of pairing roll number 408. Going to present a seminar on binary codes in switching theory and logic design. Binary codes. Binary codes are systems for representing numbers, letters, or other information using only two symbols, 0 and 1. They are fundamental to digital electronics computing and circuits are naturally because digital circuits are naturally a two-state on or off. As we know that in digital circuits we only use binary codes. There is only two inputs 0, 1 or on or off. So why are only binary codes are used and not? Then there are many other codes, but why they are not? So there are some reasons why only binary codes are used. Reliability. Digital signals with only two states, high or low or 0 or 1, are less affected by noise. Another simplicity. Hardware like transistor naturally work with two states. Means transistor is transistor hardware is inbuilt with only two states on or off or 0 or 1. Compatibility. Computers and microcontrollers process binary data directly. So computers and microprocessor, if we insert binary data, they can process directly without any complexity. Now, binary codes are mainly classified into two types, as we can see. Types of binary codes are first, first one weighted binary codes and another is non-weighted binary codes. So first let's see about weighted binary code. Weighted binary codes. Each digit has a fixed weight, means power of two. Examples are straight binary, natural representation, binary code decimal BCD. Each digit from 0 to 9 is represented by only 4 bits. As we can see example, decimal 59 can be represented as 0101, 1001 in binary coded decimal. And our another type in binary codes is non-weighted binary codes. So non-weighted binary codes have no positional weight, means no positional weight is assigned to bits in non-weighted binary codes. Examples are error detecting codes such as parity codes, checksums, etc. And also error corrected codes are also examples of non-weighted codes such as Hamming code, BCH code, etc. So till now we have seen what are binary codes, what are types of binary codes, and why binary codes are reliable. So now we will see some commonly used binary codes. As you can see, some commonly used binary codes are BCD, but that is binary coded decimal, which has each decimal digit stored as 4-bit binary. As we can see, as previous example, decimal number 59, which is stored as 010145 and 100149. So this is not a combination of 1101. It is like 5 separate and 9 separate, such as 0101 and 1001. You can observe that. Excess 3 code derived by adding 3 to each BCD digit. For example, let's take a decimal number. BCD binary coded decimal of 5 is 010. Excess 3 means adding 3 to 5, which is here. And the code for 8 is 1000. As we know, yeah, as we know the code 8. So we can see some another common examples, like if we take 4 and add 3, So it will be first like 0100 and then it will become 01111. We can take so many examples like that based on our interest. Gray code. Only one bit changes at a time reduces error during transition. Example, take decimal sequence of 0 to 7 and we can write their binary codes such as by using 4 to 1 code such as 0000001 011 010 110 111 101 100. So the main motto of gray code is as only one bit changes at a time, it reduces error during transitions. So it can be used as error. So when we use gray codes, errors can be minimal. ASCII code. So only one bit changes at a time, reduces error during transition. The example is decimal sequence 0 to 7. Unicode, extended standard to represent characters in all languages. So Unicode is nothing but a extended standard or modified standard to represent characters in all languages. Example, in all computer languages or any other. As we see, Unicode uses 16-bit or 32-bit binary representation, or we can see 2 power 4 or 2 power 5 binary representation. So when we transmit certain binary data from transmitter to receiver, there there may be error occur. So there is a necessity of detecting the error and correcting the error. So, such codes, certain codes are required to detect the error and correct the error. Such codes are called error detecting and error correcting codes. So first one we can see parity. Parity bit is nothing but it adds an extra bit, means adding an extra bit to make total ones even or odd. If the ones are even, we call it even parity, or if ones are odd, we will call it as odd parity. And the next one is Hamming code. It corrects single bit errors by adding parity bits at specific positions. As we know, Hamming code corrects single bit errors by identifying parity bits position and solving by using even parity and odd parity. CRC, cyclic redund- redundancy check. It detects burst errors by using polynomial decay. So CRC can be used for certain kind of errors. Parity codes. So now we will see about parity codes somewhat clearly. Even or odd parity means we add a bit to make the total number of ones even or odd. So as we know, if ones are even, we call even parity, and ones are odd, we will call it odd parity. Use. As we know, use of parity code is for error detection and transmission from transmitter to receiver when any error occurs. Example, as we see, data 1011 even parity bit is equal to 0. Total ones are 3, so it is odd. So we add 1 to make it even. And the another error correcting code is Hamming code. It adds multiple parity bits at started equal positions, means at powers of 2, to detect and correct single bit errors automatically. So this helps a lot in correcting errors. received by the received by the receiver. So we can conclude by seeing certain applications of binary codes. Binary codes are binary codes are very versatile applications, but it is mainly used in digital electronics and computing as we design digital circuits only based on binary codes and some Boolean laws, etc. So we can see first application is that digital electronics and computing. Second one is data transmission and communication. As we saw previous, we can detect and correct if any errors are present in transmitting. Third one is digital control system, means it is used in digital circuit making. Fourth one is data storage. Fifth one is text and multimedia representation. So this is some information on binary codes. Thank you.